Hello everyone, welcome to this video. Let's start with the solution of LTC MPL chemistry weekend test 14. First question, which one of the following is a semiconductor? Of course, the answer is cupric oxide because silver and graphite, these are conductors, and Teflon is an insulator. Molar conductance of decimolar strong electrolyte is given, specific conductance is asked, right? So guys, molar conductance is kappa into 1000 divided by C. So molar conductance is given 270 and concentration is given decimolar 0.1. So substitute the values, you will find out the value of kappa, okay? Then specific conductance is directly proportional to concentration. So 1 molar HCl will have the highest specific conductance. And molar conductance is the conductance due to 1 mole of electrolyte. Because CF3COH is the strongest acid, here it will give the maximum number of ions because its degree of ionization is highest here. Okay? So this will show the maximum molar conductance. Debye-Hückel equation lambda m is equal to lambda infinity m minus a under root c is applicable to strong electrolytes, not to weak electrolytes. So acetic acid is a weak electrolyte, it will not be valid. Okay. Molar conductance of aluminum is given x, for sulfate it is given y. Okay. The molar conductance of aluminum sulfate would be given as per the formula, right? So aluminum sulfate, the formula of the electrolyte is this. So the molar conductance of the electrolyte would be twice the value of x and thrice the value of y. Degree of dissociation, guys, it is alpha is equal to lambda m divided by lambda infinity m. So alpha is given to be 0.1. The molar conductance, it has to be calculated, and the limiting molar conductance is given to be at infinite dilution 540. So you will find out the answer. This comes out to be this one. Molar conductance at infinite dilution for sodium acetate. So it is this. It is given to be Z. For HCl it is Y, and for sodium chloride it is X. The question is molar conductance for acetic acid. All right. So molar conductance for acetic acid, we need two ions, acetate, which will come from Z, and we need H plus ion, which will come from Y minus. We don't need Na plus NCl minus, so we'll subtract X. So Z plus Y minus X. This will be the correct answer. Aqueous solution of AgNO3 subjected to electrolysis using platinum electrodes. So what are the ions present in solution? Ag plus, NO3 minus, H plus, OH minus. At anode, out of nitrate and hydroxide ion will undergo oxidation. It comes from water. So I can write the equation as this: 2H plus half oxygen gas plus 2 electron. Alright guys. Now if you see, the pH of the solution is decreasing with the time. So this is an incorrect statement. All other are correct, right? Composition will change because it is electrolysis, and out of Ag plus and H plus, silver ion has higher tendency for reduction. So silver is deposited at cathode. Cost of electricity to deposit 1 gram of hydrogen. 1 gram of hydrogen, guys, it requires 1 mole of electrons, which is 1 Faraday. Its cost is rupees 600. Now cost of electricity to deposit 3 gram of magnesium. Now the molar mass of magnesium is 24 gram. And it requires 2 Faraday. So 3 gram of magnesium would require how much? 2 by 24 multiplied by 3, which is 1 by 4, which is 0.25 Faraday. So the cost of 1 Faraday is 600. The cost of 1 by 4 Faraday will be 150. Electrochemical equivalent is equal to the equivalent weight divided by 96500. Okay. The electrochemical equivalent weight Z is denoted by so Z is equal to equivalent weight by 96500. So you multiply these values, you will get the equivalent weight to be 108. Okay. Units of electrochemical equivalent as per the Faraday's first law of electrolysis, W is equal to ZQ, right? The mass is equal to electrochemical equivalent multiplied by charge. So mass is measured in gram and charge in coulombs. So Z will be gram per coulomb. Aqueous solution of copper sulfate is subjected to electrolysis using copper electrodes. So incorrect statement about the process is hydrogen is liberated at cathode. No. Let us see the ions. Copper ion, sulfate ion. Out of water we get H plus and OH minus and copper electrodes. Alright. So at anode, out of copper, sulfate and hydroxide, copper will undergo oxidation, right? And at cathode, out of cupric ion and H plus ion, cupric ion will undergo reduction. So incorrect will be hydrogen is liberated at cathode. Okay. When aqueous silver nitrate is subjected to electrolysis using inert electrodes, 2.7 gram of silver is deposited at the cathode. The weight of oxygen, as per the Faraday's second law of electrolysis, mass of silver divided by mass of oxygen will be, the ratio of masses is equal to the ratio of the equivalent weights. So the equivalent weight of silver is 108 and that of oxygen is 8. So substitute the value 2.7, you will get the value of mass of oxygen, right? It will come out to be 0.2 gram. Same quantity of electricity is passed through cupric chloride, which is Cu2 plus, and cuprous chloride, which is Cu plus 1. The weight of copper, okay guys, so the mass is proportional to number of moles, right? Because molar mass is same of copper deposited from A is X and that B is okay. So the number of moles deposited is inversely proportional to n factors. So this will be 1 by 2 is to 1 by 1. Now you multiply it by 2, so you will get 1 is to 2. So the ratio of their number of moles or mass deposited is 1 is to 2. Difference in limiting molar conductance of KBr and NABr, guys, it would be the ionic conductance of K plus minus the ionic conductance of Na plus, because bromide is constant. And difference in limiting ionic conductance of KNO3 and NO3, again it will be equal to ionic conductance of K plus minus ionic conductance of sodium, because nitrate is common. So they are actually equal, okay, because they both represent K plus minus Na minus. So Na plus, so this represents X is equal to Y. Regarding standard hydrogen electrode, incorrect statement is this is correct, this is correct. It can act as anode depending upon the other substance if it is less reactive than hydrogen, okay. Correct statement about Daniel cell among the following is EMF is 1.1 volt, zinc is anode, it is negative, and copper does not reduce Zn2 plus. In fact, zinc reduces copper 2 plus, and electrons flow from zinc to copper, okay. In aqueous solution, the ion with maximum limiting molar conductance is H plus, because its high conductivity is explained using proton transfer mechanism, okay. Diborane reacts with ammonia at high temperature to form borazine, borazole, which we also call inorganic benzene, so B3N3H6 and hydrogen. Borax has 10 H2O, whereas kyanite, another ore of boron, it has 4 molecules of water. Regarding orthoboric acid, the incorrect statement is it gives metaboric acid the final product. No, it gives boric anhydride, B2O3, as the final product of heating. Other 3 are correct. How many elements of group 13th form amphoteric oxides? Okay, it is 2 elements. These are the last 2 elements, indium and thallium. Number of boron-boron bonds in the structure of diborane is 0, because it does not have bonds between the boron atoms, right? Alright. Transition metal ions can be detected with the help of borax bead test. Formula and color of the bead formed by cobalt. So the metaborate is a product. So all these 3 are eliminated. This is the correct answer. And the color of the cobalt borax bead is blue. This electrode potential is positive. Yes, because thallium 3 plus is a strong oxidizing agent. Because of the nut pair effect, its +1 state is more stable. Thallium triiodide is highly stable. Thallium in +3 state actually cannot exist with the iodide ion. Alright, it gets reduced to thallium +1. So thallium 3 plus iodide is not does not exist. It is not stable, right? So statement 1 is correct. Statement 2 is incorrect. Least reactive compound towards electrophilic substitution reaction would be this one, because we need electron donating group, but this is an electron withdrawing group. Reactivity of this is greater than this towards electrophilic substitution. No, phenol is more reactive because of the plus M effect. OH group of phenol shows -I, correct. -M, no, it shows plus M effect. So this is both statements are incorrect. In this reaction, the X is anhydrous AlCl3. It's a Lewis acid catalyst. The reaction is Friedel-Crafts alkylation reaction. Benzoylation, guys, is the reaction of a compound with benzoyl chloride. So of course it is Friedel-Crafts acylation. The product would be benzophenone, that is benzene ring, then carbonyl group, and then benzene ring. Regarding the electrophile and sulfonation of benzene, which is SO3, it is a positive electrophile. No, it is a neutral electrophile. All other 3 are correct. All the following show -I, -M effect on benzene ring except OCH3 because of the presence of lone pair. It shows -I because it is electronegative, but because of the presence of lone pair, it shows +M. Okay. So this is the correct answer. Reactivity of chlorobenzene towards substitution nucleophilic aromatic reactions is almost same as that of this, because the presence of electron withdrawing groups at ortho and para position increases the reactivity. If the electron withdrawing group is present on the meta position, it does not affect the reactivity very much. Methyl halides react by SN2, yes, because it is sterically unhindered. Tertiary butyl halides prefer SN1, yes, because it gives stable carbocation. So both statements are correct. Heterolytic cleavage of CCl bond is easiest in which case? In this case, because the cleavage would produce benzyl carbocation, which is highly stable, right? In other cases, it is a phenyl cation, not stable. How many of the following are non-reactive towards nucleophilic substitution? So this is phenol. It undergoes electrophilic substitution, not nucleophilic. Vinyl halides, they are not they don't react by SN1 SN2 mechanism, right? And then this is also a vinyl halide, and ether. This is diphenyl ether, okay, benzene and then oxygen and then benzene. So none of them react. So answer is 4. A is a strong electrolyte, B is a weak electrolyte. Decimal solutions of both are taken in two separate vessels. If both these are diluted to the same extent, the correct statement is, of course, you know guys, the increase in molar conductance with dilution for a strong electrolyte is very small, because the ionic mobility increases by a small extent. But for weak electrolyte, it is the increase in degree of ionization which prominently increases molar conductance. So increase in molar conductance of B will be greater than that of A. Molar conductance of 0.4 molar strong electrolyte is X. Specific conductance of the solution, again you can use this formula. So you can calculate, okay. So this will come out to be this one. Which one of the following electrolyte does not liberate oxygen at anode during electrolysis carried out using inert electrode? So in aqueous case Cl, the ions will be K plus, Cl minus, H plus, OH minus. Now out of chloride and hydroxide, chloride will show a greater tendency for oxidation. Chlorine will be formed. So this is the correct answer. 1 Faraday of electricity can decompose, okay, for water, the decomposition electrolysis equation can be written like this: H2 plus half O2. So you can see the N factor of the reaction is 2. That is, it requires 2 Faraday of electricity per mole. So 1 Faraday will require half a mole, okay. Units of Faraday, coulomb per mole, because it is a charge on 1 mole of electrons. Aqueous solution of NaCl is subjected to electrolysis. Weight of the substance obtained at cathode. Okay, so cathode, out of Na plus and H plus, hydrogen will be deposited. It will be H2. Weight of the substance obtained at cathode by passing itna current for 10 seconds. Okay, so W, what will be the W is equal to ZQ. All right. So equivalent weight of hydrogen is 1 and 96500 multiplied by charge, which is current into time. 9650 ampere current for 10 seconds. So this will be 1 gram. That is the answer. Least reactive towards substitution nucleophilic aromatic reaction is this one, because we don't want electron donating groups, okay, particularly at ortho and para positions. The principle on which the selection of electrolyte of the salt bridge used in a galvanic cell is based on both cation and anion must have similar ionic mobilities, that is the similar transference or transport number. So this is the correct answer. Most electropositive element of 13th group is aluminum. So it is amphoteric. It shows both. Shows reactions with both acids as well as alkalis. Correct statement about among the following about group 13 elements is the correct statements are A and C. Highest density thallium increases down the group, right? The highest boiling point with thallium, no boiling point decreases down the group. The element with least ionization potential is indium. Yes, ionization potential decreases down the group, but out of indium and thallium, thallium has a little bit higher value because of the poor shielding effect of 4f electrons. Okay. The element with least electropositive nature is indium. No, aluminum is least electronegative. That is okay. So this is not the correct answer. Incorrect statement about among the following about gallium is its boiling point is very high, its melting point is very low. So it is a wide temperature range in liquid phase. So that's why it's used in high temperature thermometers. Which of the following species is least stable? This one, because the carbon which carries the positive charge is directly joined to one of the most powerful electron withdrawing groups. So this is least stable. In this case, because the reaction occurs by SN1 mechanism, removal of chloride will give you a carbocation, and then 1,2-methyl shift will occur. So this will lead to the formation of more stable carbocation, okay, which is stabilized by the hyperconjugation of methyl and the resonance of phenyl, okay. So this would be the correct answer, and then hydroxide will attack here, okay. This reaction is nitration. Regarding this statement, correct statements are: electrophile is nitronium ion. Yes, it is NO2 plus. The product is nitrobenzene, correct, and nitro group deactivates benzene, so it is less reactive than benzene towards electrophilic substitution. Fine. A on electrophilic substitution gives para-isomer. No, NO2 is a meta-directing group, so the further electrophilic substitution of nitrobenzene will give you a meta product. So ABC are correct, D is incorrect. Thank you guys.